Don't know why I'm recording already, but whatever. So today is the 13th. This will be another tricky one for notes, just because I'll be doing graphy stuff. So you'll just have to kind of freestyle, make do. I have faith in all of you that you can do this. I made myself a little note card. So this is the first. Oh. This is the first example. And so I would write that down. This next part, I don't want you to write down. I'm just going to change colors real quick. And the reason I do stuff like this is because I just like to give you perspective on where we've been as opposed to where we are and where we're going. Okay. If I asked you to graph the red equation, you've proven to me that you don't have any issues with that. What makes the red one so easy to graph? Because y is by itself, which means if someone said, hey, graph the red line, I would just simply have to start by going up 5, put a dot, boop, and then from that dot, utilize the slope, down 1, right 2, boop, make some dots, make a line. Like that's graphing at its simplest, right? Slope intercept. So that's where we've been. Where we're headed is, can I graph a line when it doesn't look like that? And what we learned quickly here today is that, yep, you can. In this nice format, remember, this is the one we've been talking about called point slope. This is nice. You can actually graph this about as quick. Um, but there's a leap here. There's kind of a jump you have to make before you can get your foot in the door. So we do know one thing about the line. What's its slope? We know that. So we know that the line, wherever it sits, is going to go down 1, right 2, down 1, right 2 forever. We know that. But what we maybe don't know is where to start, because this doesn't have that nice, cute little y-intercept for us to just say, oh, I'll just go up 3 or down 5 or something like that. Does anyone have a strategy perhaps that I could use? It's real quick. Good thinking. And the day will come when I do want you to actually do math. But what I'm asking you to do right now does not involve math. I just want you to look at the equation and make an observation for me. This is strongly related to what you already know how to do. Do not distribute. I don't want you to do any math at all. There will be no mathematical operations happening here today. None. Think backwards. Think about what I've been asking you to do and ask yourself, what math problem would have had to exist for this to have been the answer? Imagine backwards that I had given you a math problem and you wrote this as your answer. Hannah? Correct. That's huge. You can look at this equation and reverse engineer a fact. And a fact is that this line has to go through the point -3, -4. Let's think about this for a second. If I had given you that information, forget everything you see written in white. Forget the graph off to the right-hand side. If I had given you a problem yesterday and said, write me the equation of a line that passes through the point -3, -4, and has a slope of -1/2. Let me scroll up just to make this kind of disappear. If I gave you that and said, write me the equation what would you write?
Y plus 4 negative 1/2 of x plus 3.
Good. And now I'm going to scroll up just so you can see that, in fact, the two white things are identical. Good job, Hannah. So by reverse sort of engineering that fact, the point that the line goes through, we don't need a y-intercept as a place to start. I just need a point from which to start jumping. It doesn't have to be a y-intercept. It's convenient when it is, but that doesn't mean all hope is lost when it's not. So potentially unnecessarily long story short, you go to the point that the equation gives you and you graph it. So the point that Hannah gave us is -3, -4. So I will go on my graph to -3, -4, and I will mark that. I treat this in my mind the same way that I would treat a y-intercept, as it's the place from which I'll now make subsequent points. And what did you say the slope of this line is? So I just simply from there go down 1, right 2, down 1, right 2, down 1, or up 1, left 2, up 1, left 2. You do that a bunch of times. Presto, you got a line. Just because I don't have a y-intercept doesn't mean I don't have a place to start. We lost. I'd say I'm maybe about 20% of you are like, I'm good. Let's see if we can, after this next example, get it up to like 40 or 50. So for our next example, I'm going to give you this equation and you're going to help me graph it. Y minus 1 equals 3 times x minus 2. I have to be able to read that equation and determine a point that I know it passes through. And I get that information out. I extrapolate that from the given equation. What point does this line go through? No. 2 comes from here. So the x coordinate is 2. 1 comes from here. So the y coordinate is 1. Therefore, the point is 2, 1. What is the slope? And again, I don't need a y-intercept. I have a point. My point can be anything. I'll take whatever I get. Give me a place to start, please. And then from there, I can make my little slopey jumps. So I'm going to go to the point named 2, 1. Right 2, up 1, make a mark. And I'm off. From that point, I will create more points by just utilizing a slope of 3. Talk me through a slope of 3. What does that mean?
Right.
Yeah, slopes need to be thought of at least. They don't need to be written this way, but they need to be thought of as fractions so that we have a rise and a run. And it's positive, so my line had better look positive. So I'm just going to go up 3, right 1, up 3, right 1, up 3, right 1, down 3, left 1, down 3, and so on and so forth. It's not any harder than it is when it's y equals mx plus b. It's just new. It's a new perspective. At the end of the day, I go in there and I just say, what's my mission? I need a place to start and I need to slope. That's it. You give me a starting point and a slope, I'm golden. Good to go. Okay. We'll go again. So again, it's one of the hardest things, especially in a class with 23, 24, is I don't have the benefit of being able to sense your understanding. So I'll have to rely on your honesty here. What I need to know is if all of you can look at this equation and name for me a point that the line goes through. The equation is speaking to you. It's giving you information. Riley, what's the x coordinate of the point that this line goes through? Say it again. Absolutely, man. Grady, what's the y coordinate of the point that goes through?
-2.
Nice job. And we're out. Slope is always just going to fall into your lap. You don't even have to think sign change, or there's no thought at all. The slope just falls right out of the equation, right into your lap. You can see it. It's just sitting there staring at you. So you simply go to the point. In this case, that would be right 1 and down 2. That's the point 1, -2. And then you utilize the slope to find subsequent points. So that's going to be an up 3, right 4 travel, or conversely, a down 3, left 4 travel. You do that a couple more times. Okay. One more, and hopefully I'll have us all. And if not, then I think at that point it would be incumbent upon each of you to either say, could we do another one? Or when I give the assignment out, then you can just get the help you need. Either way would be fine. This last one's going to look a little bit different. Okay, but we're not scared. Y is by itself, but it's not in y equals mx plus b. This technically is still written in point slope form. All right. There comes a point where I just totally green light you to do this however you want. Just empower yourself, flex on me, show me, distribute, move things around, whatever. But today, my goal is, can you just leave it in its point slope form and make the graph? What is the x coordinate of the point that this line travels through? It is -4. What's the y coordinate?
Here.
It is 0. Because you could make a case right here that instead of this just saying y, you could make a case that it says y -0, which is weird, but it would still work, right? So boom, I got my point, and the slope again will just fall right into my lap. The slope is -2. And so I travel to the point and begin my journey from there. Describe to me, how do I get to the point -4, 0? Left 4. Good. That's what I wanted to hear. Good. Remember, the x coordinate goes first when you're graphing points. So we go left 4 and then stay put. And how do you describe a slope of -2?
Right.
Down to right 1, right 1, right 1, right 1. You got to make sure, you know how I feel about this, that if the line says a negative slope, it better look like a negative slope, right? You're always in control of that. And you decide, do I go right or left? That's what makes the decision. So that's a short lecture. Do you have any questions? I will say this before I end the recording. The assignment I hand out, I'm gonna, after I hand it out, I'm gonna get your attention back, and I'm gonna just tell you which points I want you to use for the first couple pages. Because I don't want to do this thing again where my answer key has to have like 3 or 4 different answers. So I'm going to tell you what point I need you to use. When that time comes, I need you to write that down so that we're all on the same page. Okie dokie? Uh-huh. Sure. Yeah, so for number 1, holy fat pen, Batman. So for number 1, use the point 2, 5. Okay. For number 2, please use the point -6, -2. For number 3, please use the point 1, 2. For number 4, use the point 2, -5. I say I wouldn't worry about graphing these right now, just write them down. Number 5, please use 7, -6. Number 6, please use -2, 6.
What?
2, -2, 6. I'm writing them down as I go, okay? On the second page, problem 7, Please use -5, 1. For number 8, please use -3, 1. Number 9, 2, -5. Number 10, -5, 3. Number 11, please use -3, 5. And then for number 12, please use the point 3, 2. That way there, the 12 answers, when I write them and scan them and post them, will match yours. Okay? So today, the rest of the time, I'll keep the recording alive, but dead, and well, not dead, but paused. If you have questions, you got to just let me know. You're going to be working on finishing the assignment from yesterday, which you're probably pretty close to done with, and then also trying to finish the one today, assignment 31. So we're really hitting point slope pretty hard here these couple days. Any questions? Okay, cool. Let me pause this again real quick. I wasn't quite ready. So in problem number 1, I had asked you to use the 0.25. So I'm going to write that down. I write it always kind of in whatever open space I can find. What's missing is this. I'm going to write m equals, and it's just going to be blank right now. I can't go, listen, this is going to be the theme for the next 2 weeks. No slope. We're at a road. We're at a no pass. Okay. Slope is everything. So even though I gave you the 0.25, which is right here, or I didn't give it to you, I asked you politely to use it. You need of your own free will to go find me some other point, preferably one that's kind of next door neighbors-ish so that I don't have to go too far. The next point that I see, the one that just catches my eye, is this purple point right here. That's not to say that that would be the one that you'd see. It's just my eyes tend to go to the right. So that's the point that I see. You don't need to write down the name of that point because you already have the one that I've asked you to use. What you do need the purple point for, though, is to find the slope of the line. And now that you have the point and the other point, you can see the slope. What is the slope of this line? You can count it out. It's up 1, right 1, 2, 3. So by definition, the slope is 1/3. Every time I ask you to do a problem like this, before you write the answer, I should see 2 things written on your paper. I should see the name of the point which you've elected to use. I'm not going to try to read your mind. That should be written down, and I should see the slope that you have observed. Those 2 things are what build the answer. I need to see those. You should need to see those too. And now that I have them, I'm going to write the equation just the way we have been. So I'm going to go y minus the y coordinate, which is 5, equals slope times x minus the x coordinate, 2. Because remember, the point that we've agreed to use is right here. So again, that's the flow, and I can do another one if you want. I'm giving you a point, but then it's incumbent upon you to find another. You just, it's kind of you don't have to talk to me about the other one. Just know that you need it, right? So in problem 2, I asked you to use the point -6, -2. It's right here. So I'm going to write that down up at the top of the problem. You should as well somewhere. So the point's name is -6, -2. The next good point, that I see as I move my eyeballs down this line is right here. That purple point is the next one that is a lattice. It hits on a grid. So I don't need you to name that point. That's just going to clutter up your paper. What I do need from you is to write down the slope. So right now I write m equals blank. I don't know what the slope is, but you have practiced this enough that you can look at those two dots and tell me what the slope is. It's negative something. And before anything else, I'm just going to write the negative sign so I don't goober head it and forget the negative. So let's count it out. I remember to always rise first and then run. So we're going to go down 2. So the top of your slope is 2. And then we're going to run 3. 1, 2, 3. So our slope is negative 2/3. And now that you have these two pieces of information written down, there's nothing stopping you from writing the answer to the problem. I have everything I need to write a point slope equation. So it's going to say y minus -2, aka y plus 2. See, I change it to plus when I'm about to smack a double negative in there. Equals -2/3 times x minus
plus
-6. So it becomes +6. And we go again and again. You feeling that? I will, when the time comes, we're not at quiz point yet. Okay. We're several days away from that conversation. I will just forewarn you that you will either receive or lose points for either having these two things in green that I have or not. You need to have those. They're communicative for yourself, but they're also communicative for me. So when I'm at home grading, I need to know, oh, okay, so Michaela used this point and this is her slope. So these are not just window dressing. Those green circled things are critically important.
Mr. Another question.
Good?
Yeah, way better.
Fantastic.
On number 3,
Number 3.
it says you could be use 1 and 2, which I did, and then I went up 3, then left 1,
I like that point.
and then but I didn't know if the 1 since I go back, it's the positive part of the
Let me get caught up to you real quick. So the point that we're using, we agree, is 1, 2, right?
Yeah.
Okay, so then I'm going to write m equals. And listen, this is a conversation that will never go away in my line of work. Before we just talk about, I went left, so is it this, or I went up or down, I got to just ask you to look at that line. Just look at it. Forget math and just look at the line. Does it go uphill or down?
townhouse.
So the slope is negative. So at the end of the day, when you and I count out the slope, we don't have to talk about positives and negatives anymore. We just have to talk about distances, right?
Okay.
So if you go from the red point to the purple point, you make a vertical jump, a rise, we call it, of 3. You make a horizontal jump of 1. Notice I did not say -1. We've already crossed that bridge, right?
Okay. Yep.
So the slope,
I mean, like 3.
it does. Slope can be so simple if we just remember to look at the line as a big picture first. And then don't worry about all the mathy stuff, right? They're just distances.
And then I get
Mhm.
-3 times -1.
Done.
Like,
Anytime. The fact that you got to here and then asked tells me that you're probably asking about the fact that there's no slope there.
Yeah.
Yeah. So let's first write down the name of the point. So what point does this line go through? Say again. Mm-mm.
What'd you ask?
What point does the line go through? I'll say this. I like the 6. I don't like the +2 though. I'm not.
Oh, negative.
So -2, +6 is the name of the point that it goes through. I like that. So I'm going to go to that point real quick and I'll graph it. So there it is. The slope, as you've seen this all year, it gets so annoying in algebra for you guys. I know that there are numbers sometimes that are invisible. What number is there that you just can't see? You know this. We've been doing this all year. Like if I put like X, what's in front of it right there? Right. And the same can be said like that negative is like a -1. So the slope is -1. What's that mean for us, Kobe? When I go to find points, how does a -1 slope work? That's cool. Yeah, boy. There you go. So just like that. Good?
Yeah.
Yeah. And you'll have another missing number on number 20, but we went over that in the notes, so it should be okay.